Hello, welcome to Math 1960, Section 301. It's your UNO Summer Session number 3. Today we're going to discuss approximation using Taylor or Maclaurin expansion. We will approximate function and its graph using Taylor polynomial. We will approximate the number e, and we will approximate the definite integral. So here, how do we approximate a polynomial? So first of all, find the Taylor polynomial p of n of x for f of x. So we know that when we have this type of f of x, we want f of x at 0. This will be Maclaurin series, and in Maclaurin series, the expansion is given by this. So it's going to be equals to f of x equals to f of 0 plus f prime of 0 x plus f double prime of 0 x squared over 2 factorial plus f triple prime of 0 over 3 factorial and so on. And then this is the e expansion that we already know, which is going to be equals to 1 plus x plus x squared over 2 factorial plus x cubed 3 factorial plus x to the fourth 4 factorial and so on. So then p of n is going to be equals to 1 plus x plus x to the second 2 factorial plus x to the third 3 factorial plus up to x to the n over n factorial. So that would be your p of n. So here we're going to use the Taylor series polynomial for p of 7 for sine of x at 0. This is also going to be Maclaurin series. So then, as we know, Maclaurin series has the following formula. So f of x is going to be equals to f of 0 plus f prime of x plus f double prime of 0 x squared over 2 factorial plus f triple prime of 0 x cubed 3 factorial and so on. So our function here, which is f of x, is equal to sine of x. So f prime of x is going to be cosine of x. F double prime of x is going to be equal to negative sine of x. And then f triple prime of x, that is going to be equal to negative cosine of x. And then f 4 of x going to be equal to positive sine of x, and then of x is going to be equals to positive cosine of x. So then on this side we're going to get 0, 1. This is when we plug in 0, 0, negative 1, and then 0, positive 1. So then the expansion is going to look something like this. F of x is going to be x minus x cubed over 3 factorial plus x to the fifth 5 factorial minus x to the 7 factorial, and so forth. And then so a piece of 7 here is going to be x cubed over 3 factorial plus x to the fifth 5 factorial minus x to the 7 factorial, and so forth. So, and then when we plug in 0.1, so we're going to get 0.1 plus 0.1 to the third divided by 3 factorial. This is negative here. Plus 0.1 to the fifth 5 factorial minus 0.1 to the seventh over 7 factorial, and that gives you 2.756 times 10 raised to the power of negative 15. So, and so the error in that, so this is like the P7 when we graph it with the sine x. So the error is going to be E, which is the error, should be less than or equals to a sub n plus 1. And then this error happened to be, it's going to be equals to 0.19 factorial. And that is going to give you 0.0 it's going to give you 2.756 times 10 to the negative 16. So here if we go back, the answer actually is not this. The answer, when we sum these up, sorry for that, the answer should be equal to 0.0998. So now we want to find the Taylor polynomial P4 for ln of x. Well, to find this, first, so first of all, we are going to find f of x is going to be equals to ln of x, and then f prime of x is going to be 1 over x, then f double prime of x is going to be equals to negative 1 over x squared, and then f triple prime of x is going to be equals to 2x raised, and then we're going to find f of 1 f of 1 is going to be equal to 0. F of f prime of 1 is going to be equal to 1. F prime of f double prime of 1 is going to be equal to negative 1. F triple prime of 1 is going to be equal to 2, and then f of the 1, that should be equal to negative 6. So then my Taylor series would look like this: f of x equals to x minus 1 times x minus 1 squared over 2 factorial plus 2 x minus 1 cube over 3 factorial minus 6 x minus 1 to the fourth 4 factorial plus, so that would be the expansion itself. So at this point we are going to approximate E so that the error is less than or equals to this number. So to approximate E, first of all, the E expansion using Maclaurin series is going to be equal to 1 plus x squared over 2i over 2 factorial plus x cubed over 3 factorial plus 4 factorial and so forth. So now we are going, because if we use e raised to the power of 1, we're going to get 1 plus so this doesn't converge easily, so we're going to use, which is going to be like this. So it's going to be alternating series, and then later on we convert into this, we convert that into this. So factorial. So now now let's so our error, which is basically 1 over n factorial, must be less than or equals to 1 over 10 into the 6. That means 10 into the 6 is less than or equal to n factorial. So that happened to be 10 into the 6 is less than 10 factorial. So that means we are going to count from 9 factorial downward. So that means e to the n, we're going to count from 1 minus 1 plus 1 factorial minus 1 over 3 factorial plus 1 over 4 factorial up, okay, all the way to 1 over, plus 1 over 5 factorial. This is going to be negative, and then here positive 1 over 6 factorial and minus 1 over 7 factorial, positive 1 over 8 factorial minus 1 over 9 factorial. We're going to sum these up. So if we sum these up and then we convert the e, we should get 2.7828. So that is how you would convert it. Here we are using the e the e approximation or the e expansion of Maclaurin series. So our integral is going to be between 0 and 1/2 of these 3 terms, or 4 terms rather, x to the second plus x to the fourth 3 factorial 2 factorial minus x to the fourth 3 factorial d of x, and then we should get 0.4614 5 8.